Hello student, myself Rajendra Kumar, Senior Lecturer Civil at Government Polytechnic College Batala. Today I am going to deliver a lecture on subject steel structure design. The topic of my lecture is welded connection. Well student, the first question is what is welded connection or what is the definition of a welded connection. So, when the two members are joined together permanently by welding, the connection is called welded connection. So, when two members are joined together by means of welding is known as welded connection. Such connections are widely used nowadays in fabrication. So, in fabrication generally welded connection are used. Many welding process have been developed, but each process is different in different manner in which heat is applied and in the type of equipment used. So, different type of welded connection are used based upon the manner in which the heat is applied and in the type of the equipment used. Different welded connection are used in the manufacture of automobile body, aircraft, high speed railroad cars, machine frames and structural works etc. So, for the manufacturing of automobile body, aircraft, high speed railroad car, machine frame and structural work etc. the welded connection are used. Most of the machine part are now made up of steel member welded together. There is hardly industry today in which the welding is not used for providing the welded connection. Come to the next welding. What is welding? The process of permanently joining two or more metal part under the application of heat with or without pressure is known as welding. So, welding is a process of permanently joining two or more metal part under the application of heat with or without pressure. If the pressure is used for joining the two part, the process is known as forge welding. So, when pressure is used while welding, that type of welding is known as the forge welding. If the two parts are joined without any pressure, but with a separate weld metal, the process is known as fusion welding. So, when pressure is not used while welding, so that type of welding is known as fusion welding. The heat of melt for the weld metal is generally obtained by the gas welding or by the electric arc welding. So, the heat produced from the gas welding or electric arc welding is used to melt the metal. So, this is welding. Next, come to the next point, advantage and disadvantage of a welded joint. So, let us discuss at first advantage of the welded joint. So, first advantage is the welded structure are comparatively lighter than the corresponding riveted structures. So, welded structure are lighter than the riveted structures. The welded joint has greater strength as compared to the riveted joint. Hence, efficiency of a welded joint is more than that of a riveted joint. So, welded joint is stronger than the riveted joint. Third advantage, the addition and alteration can easily made in the existing welded structures more easily in the riveted structures. So, welded structure easy to addition and alteration. Next advantage is a welded structure has better finish and appearance than corresponding riveted structure. So, there is better finish in the case of welded structure as compared to riveted structure. The maintenance and painting cost for a welded structure is less than the riveted structures. So, next advantage, the welding takes less time than riveting. So, welding process is faster than the riveting. In welded connection, the tension member are not weakened as in the riveted joint. So, there is no rivet hole, therefore, the tension member are not weakened as in the riveted joint. Next advantage, member of such shape which are difficult for riveting can easily be welded. So, welding is easy where there is problem of riveting due to the shape of member. It is possible to weld any part of structure at any point, but riveting require enough clearance. In the case of welding, enough clearance is not required. No noise is produced during the welding process. So, welding is less noisy than the riveting. Next, in welded connection, the use of angle, gudget plate, splicing plate can be minimized and in many cases can be avoided. Lapping of steel bar in reinforced concrete structure can be reduced to a greater extent if welding is used to join them. By using the welded connection of steel bar in RCC, so least lap length is required. The welded joint have more efficiency than the riveted joint. This is the last advantage of the welded joint. Disadvantages of welded structure or welded joint. First disadvantage is welding requires skill, labor and supervision. So, there is need of skill, labor and strict supervision for welding. Due to uneven heating and cooling during the welding, the member may get distorted or additional stress may develop. The member may get distorted due to uneven heating and cooling. This is the second disadvantage. Third disadvantage of welded structure is testing of a welded joint is difficult. An X-ray examination can help us to study the quality of a connection. Fourth disadvantage is since no provision is kept for expansion or contraction in the frame, therefore, crack may develop in it. Due to the non-availability of expansion gap in welded structure, crack may develop in welded structure. Fifth disadvantage, a welded joint may fail earlier than the riveted joint if the structure is under fatigue stress. A welded joint are over rigid, so rigidity is there in a welded joint. There is a greater possibility of brittle fracture in welding than riveting. So, next type of weld. Weld may be classified depending upon the following way. Number one, position of weld. Number two, formation of weld. So, according to the position of weld, the type of weld according to their position, weld can be called as flat, horizontal, vertical, overhead, etc. according to their position where there are uses. So, according to position, the weld are classified as flat, horizontal, vertical, overhead, etc. So, this is the diagram shows the different type of weld according to their position. This is the corner butt weld. So, this when these two member are butt against each other and this weld is provided here, this weld is known as corner butt weld. This is flat fillet weld, this is vertical fillet weld, this is horizontal butt weld. So, this is plug. So, hole is there and weld metal is filled in that hole. So, this is called plug weld. This is the flat filled weld. This is slot and weld provided in the slot is called slot weld. So, this is slot weld. This is this member, this vertical member make a T section here. So, the weld provided here is known as T-fit weld, flat butt weld is there, and this is overhead fillet weld. So these are the different type of weld based upon the position of weld. Next type of weld is type of weld according to their formation. So the important type of weld according to their formation are butt weld and fillet weld. So let us just discuss butt weld. This type of weld is used when the member to be connected butt, that is touch against each other. So when member are butt against each other is called butt weld. So these are the different type of butt weld. The following type of butt weld are mostly used: square butt weld, single V butt weld, double V butt weld, single U butt weld, double U butt weld, single bevel butt weld, double bevel butt weld. So when the formation of weld is like a square, so this is called square butt weld. So second is single V. Here the formation of weld is like a V. So this type of weld is called single V butt weld. This diagram show the double V butt weld. So the formation of weld is one V is here and one V is here. So this type of weld is called double V butt weld. Single U butt weld, when the weld formed like a U shape. So this type of U is called single U butt weld. Double U butt weld, when there are two U, one U is here and next is here. So this type of weld is known as double U butt weld. Single bevel butt weld, when butt weld is inclined in shape. So this type of weld is single bevel weld, and this diagram shows the double bevel butt weld. In this, double inclination is there, one is here and second is here. This type of butt weld is called double bevel butt weld. Fillet weld. So this type of weld is used when the member to be connected overlap each other. When the member are overlapped each other is called fillet weld. There are three type of fillet weld: side fillet weld, end fillet weld, and third one is the diagonal fillet weld. So let us discuss at first side fillet weld. A fillet weld, the axis of which is parallel to the direction of applied load is called side fillet weld. It is also called as longitudinal fillet weld. So when weld is parallel to the direction of stress, so this weld is, this is the direction of stress, and this is direction of weld, this is also weld, and this is parallel to the this direction of stress. This type of weld is called side fillet weld. It is also called as a longitudinal fillet weld. Second type of fillet weld is there, end fillet weld. A fillet weld, the axis of which is at right angle to the direction of applied load is called end fillet weld. It is also called a transverse fillet weld. When the weld is perpendicular to the direction of stress, so this weld is perpendicular to this direction of stress. So when the weld is perpendicular to the direction of stress and parallel to the meeting edges, so these are the meeting edge of the member, these are the meeting edge of the so weld which are perpendicular to the direction of stress and parallel to the meeting edge of the member is called end fillet weld, and it is also known as transverse fillet weld. So this diagram show the end fillet weld. Third type of fillet weld is diagonal fillet weld. A fillet weld, the axis of which is inclined to the direction of applied load is called diagonal fillet weld. So when weld is inclined to the direction of stress is called the diagonal fillet weld. So, this weld is diagonal fillet weld. This is inclined to the direction of stress. So, this type of weld is known as diagonal fillet weld. So, this is the side fillet weld, this is the diagonal fillet weld, this is the end fillet weld, this is again diagonal fillet weld, and this is the side fillet weld. Next important term used in design of fillet weld. The important term used while designing a fillet weld are as follow. First one is the size of fillet weld. The section of a fillet weld size for design purpose will be taken as an isosceles right angle triangle. The length of either of equal side of the triangle is called the size of weld. So, the shape of the fillet weld is like a equilateral or isosceles right angle triangle, and side of that triangle is taken as side of weld, and size of weld is denoted by S. So, size of weld is denoted by capital S. So, this is diagram for our fillet weld. In this diagram, this is the root of weld, root of fillet weld. This is called fusion face, fusion zone. This is called fusion face. This is called toe. This is again toe. This is leg, or this leg is taken as the size of weld. This is effective throat thickness. The distance from the root, this is the root, the distance from the root, the line joining of its toe. So, line joining its toe, the distance, the normal distance from the root of the weld to the line joining its toe is called effective throat thickness. This is called weld face. Next, minimum size of fillet weld. Minimum size of fillet weld for different plate thickness has been recommended by Indian Standard 8/16/1969 as follow. So, thickness of the thicker member. So, here is a thicker member, minimum size up to and including 10 mm. The minimum size of weld is 3 mm. So, the member of the plate or member which has thickness up to or including 10 mm, then the minimum size of weld, fillet weld is 3 mm. Over 10 mm up to and including 20 mm, for that the minimum size of weld is 5 mm. Over 20 mm up to and including 32 mm. So, from 20 mm to 32 mm, the minimum size of weld is taken as 6 mm. Over 32 mm and up to and including 50 mm. So, from the thickness of thicker member from 32 mm up to and including 50 mm, the thickness, the size, minimum size of weld is 8 mm for first run and 10 mm minimum. So, these table shows the minimum size of fillet weld based upon the thickness of thicker member. Maximum size of the weld. Maximum size of the fillet weld applied to the square edge should not exceed the thickness of the edge minus 1.5 mm. So, in the case of square edge, the maximum size of weld is equal to B minus 1.5 mm, where B is the side of that square. For the case of rounded toe, maximum size of the fillet weld applied to rounded toe of rolled steel section should not exceed 3/4 into thickness of the rounded toe. So, in the case of rounded toe, the maximum size of weld is equal to 3 into diameter of a rounded toe. Usually weld size closer to the minimum size is selected for the following reason. So, generally we prefer the minimum size of weld due to the following reasons. First reason is there, larger size of welder require more than one run welding, which mean that after the first run of welding, chipping and cleaning will be required for the proper bond of the successive weld run. This increase the cost. So, large size welder require chipping and cleaning for more than one run of welding, which increase the cost of welding. Second reason to prefer small size the minimum size weld is smaller size weld will be cheaper than a larger one for the same strength considering the volume of welding. So, smaller size weld is cheaper than the larger one. Effective throat thickness. So, the distance the perpendicular distance between the hypotenuse of the triangle and the opposite apex is called the effective throat thickness. So, the normal distance from the root of the weld to the line joinings its toe is known as effective throat thickness. It is denoted by small t. The effective throat thickness is calculated as effective throat thickness is equal to K into size of weld. So, K, where K is the constant and the value of K is depend upon the angle between the fusion faces. The value of K for different angle between the fusion face is adopted as per following table recommended by Indian Standard 816 1969. So, this is the table where this is the angle between the fusion faces, the value of constant K. So, when the angle between the fusion faces is from 60 degree to 90 degree, then the value of K is taken as 0.7. When the angle between the fusion face is from 90 degree to 100 degree, then the value of constant K is taken as 0.65, and when the angle between the fusion faces is 101 degree to 106 degree, then the value of K is adopted as 0.6, and similarly when the angle between the fusion face is from 107 degree to 113 degree, then the value of K is taken as 0.55, and when the angle between fusion faces is 114 degree to 120 degree, then the value of constant K is taken as 0.5. Generally, the angle between the fusion face is between 60 degree to 90 degree, and the value of K is taken as 0.7. So, this diagram of the fillet weld, this is the concave fillet weld. When the face of weld is like a concave, then this type of weld is called concave fillet weld. When the face of weld is convex, so this type of weld is called convex fillet weld, and this is a flat fillet weld. When the face of weld is flat, this type of weld is known as flat armature fillet weld. So, this is the effective throat thickness. The distance from the root of the weld to the line joining its toe is called the effective throat thickness. This is the size of weld in all the case. This is the size of weld, this is the size of weld. So, in most of the cases a right angle fillet weld is used, for which the value of K is taken as 0.7. The effective length of a fillet weld. The effective length of a fillet weld is equal to its overall length minus twice the weld of size. So, effective length of a fillet weld is taken as total length of the weld minus 2 into the weld size. The effective length of a fillet weld designed to transmit loading should not be less than 4 times the weld size, and the effective length of weld is not less than 4 into weld size. Only the effective length shown on the drawing and the additional length 2 into weld size is provided by the welder. End return. The fillet weld terminating at the end or the side of the member should be returned around the corner whenever practicable for the distance not less than twice the weld size. So, weld returned around the corner is called end return, and end return is not less than 2 into weld size. The provision, this is end return, and the length of this end return is not less than 2 into weld size. The provision apply in particular to fillet weld in tension, connecting beam, seating bracket, etc. Overlap. The overlap in a lap joint should not be less than 5 times the thickness of the plate. So, overlap lap length is not less than 5 t, lap length is less than 5 t, where t is the thickness of a thinner plate. Side fillet. In a lap joint made by a side or longitudinal fillet weld, the length of each fillet weld should not be less than the perpendicular distance between them. So, the length of each side fillet weld is not less than the perpendicular distance between them. In diagram, so this distance is not less than the perpendicular distance between these two fillet weld. So, L is not less than D. The perpendicular distance between the side fillet weld should also not exceed 16 times the thickness of thinner plate connected. So, the D, this D, the distance between the side fillet weld is not greater than 16 times of thickness of a thinner plate. So, if this distance D between the normal distance between the side fillet weld exceed this limit, then additional end fillet weld plug or slot weld is provided to prevent the buckling or separation of the parts. So, if the perpendicular distance is greater than 16 t, then end return or slot weld is provided to avoid the buckling of a member. Intermittent fillet weld. Intermittent fillet weld may be used when the length of the smallest size fillet weld required to transmit stress is less than the continuous length of the joint. So, intermittent fillet weld provided where continuous length of weld is not required. Any section of an intermittent fillet weld should have an effective length of not less than 4 times the weld size or 40 mm. So, intermittent weld effective length is not less than 4 into weld size or 40 mm, whichever is greater. The clear spacing between the end of the effective length of the intermittent fillet weld carrying a stress should not exceed 12 t for compression and 16 t for tension, and in no case should be more than 200 mm, where t is the thickness of the thinner part joint. So, spacing between the intermittent weld is not greater than 12 t in the case of compression and not greater than 16 t in the case of tension, where t is the thickness of the thinner plate and in no case the clear spacing between the intermittent weld exceed 200 mm. Important term used in the design of butt weld. The important term used while designing a butt weld are as follow. First one is the size of weld. Size of butt weld.